Hi. So we're going to be talking about the Linux Foundation Decentralized Trust project, Besu. We're going to be talking about the roadmap, particularly the roadmap from the perspective of enterprises using the Besu project. We're going to be talking about how we manage and contribute to the Besu roadmap from the enterprise side. Because remember that Besu is a public mainnet client as well as being a client for enterprise. And we're going to talk about what's happened this year, what's new, and we're going to talk about what's coming in the roadmap going forwards. So just a recap on the Besu project. It's actually a very hardened project that's been around a long time now. It started a number of years ago, an organisation called Consensus that contributed the code originally. And there have been a number of companies, including Kaleido, that have contributed it to it over the years. And it's really established itself as the enterprise implementation of the EVM. They're used by the vast majority of projects that are starting a commissioned network. Some of the things that make it really attractive for starting commissioned blockchain projects, in addition to running mainnet nodes, is that it has a set of consensus algorithms that give, say, finality. So when a transaction makes it into the blockchain, you are certain that that transaction has made it into the blockchain because it's been voted on by a set of parties that we say a supermajority of people who are running the chain. That fundamental feature has been very hardened in the code base and been used in real production projects for a number of years. The other features include performance and the ability to efficiently run transactions at scale, day after day after day, and the ability to manage things like data integrity and resilience and backup, which sometimes for clients that only think about the public mainnet running, they think about the fact that there are so many other nodes that are going to look after the data. You don't need to think about the resilience and the HA and the DR backup of an individual node. So these are some of the things on the technical side that have made it an extremely popular project for running enterprise-grade EVM blockchains for example, financial use cases, and it is by far the most popular blockchain for financial use cases. Also, the fact that it is part of the Linux Foundation Decentralized Trust project within the Linux Foundation, Apache 2, genuine enterprise-friendly open source, has been extremely a great accelerator for having that project lock into these projects over time. As I mentioned, the roadmap for LFTT Besu is not just coming from the enterprise side. As the project stays always current with the latest generation of the Ethereum virtual machine, allows users, and is very a highly ranked client to run as part of the mainnet of Ethereum. It's used in lots of L2s, including Linear, for example. It's the reference client for Linear, and it's used across lots of different blockchain projects. There is a necessity for the engineering team that maintains Besu to always keep up with the latest requirements that come through on the public blockchain space. Companies like Kaleido, and actually we maintain the enterprise roadmap, our engineers, our protocol team really leans in to make sure that enterprise is still reflected and still has a voice inside of the Besu project. We maintain an enterprise sort of side roadmap that we keep on the LFTT website that is making sure that there are still those requirements that need to come through from enterprise and reflected into the code base. And this has been a really big year for items getting ticked off on that roadmap. So we talk about a few of these as we go through. One of the things is actually that this year has been a year where a lot of things that have been sort of cluttering up the code base, making it go slow, have been removed from the code base to make it leaner and more efficient. We'll talk about some of those features that have gone away. There are some features which seem quite low level, they're really important for enterprise, such as if nodes stop or restart or being upgraded when you've got a smaller number of them, the time that it takes for the blockchain to recover from that and quickly recover and go forwards. That was actually a really significant item. Another item that took a lot of engineering this year, which was really exciting to have happened this year, and Kaleido was very involved in this, was providing a migration path for people who've been using previous projects for enterprise blockchain, which have lost popularity over time. particularly the Quorum project, which was very popular sort of 7 or 8 years ago, was the way that people were starting enterprise blockchain projects, providing a real migration path for those chains to keep moving forwards. We'll talk about another feature which is quite interesting called Bonsai, which is another piece of very heavy engineering that happens, which is a different way of managing the state of storage, which makes running these chains much more efficient in terms of how much storage they use at the low level of the blockchain, and that was a big piece of engineering this year as well. So it's been a really significant year for the enterprise roadmap, as well as being a year that lots of things have moved forwards for EVM as a whole. It's been a very exciting year for the EVM community with, for example, the stablecoin tsunami that's been coming through this year, lots of interesting things that have been happening this year, lots of momentum in the space that's really driven a lot of interest and excitement in the EVM community, and a lot of that adoption has come to Besu. So talking about first some of the things that have actually left the project to make the code base leaner, more efficient, more able to take new features in the future. The first is really interesting, is that we've for a long time been talking about the removal of Tessera privacy support in Besu, because there are new generations of this technology and it was a big handful on the code base. So I'll talk for a minute about the project, very exciting one that I'm personally very involved in, called Kaleido, which has taken on from that, and why there's a need for these privacy features for enterprise networks. There's a feature called Fast Sync that's been removed because it's just been replaced by SnapSync, which is more efficient, and a consensus algorithm called Proof of Work, which everybody might be familiar with from the early days of blockchain and Bitcoin, and pretty much all Ethereum-based networks have moved away from that nowadays, apart from a very small number. So Besu said, look, there's no point. We don't want to encourage any use of that consensus protocol. It's very energy inefficient. It's very inefficient as a whole. So let's move to better protocols, proof of stake, and then the enterprises. There's one called QBFT, which is very efficient for permission networks. So we're going to talk in a little bit of detail, just for a minute, about privacy, because this is actually a very significant area of investment for enterprise networks right now, that are looking at building a shared ledger between financial institutions, between large enterprise institutions. If you think about coming together and sharing a blockchain network, it's about shared data. It's about transacting together on a single network. And EVM is the most popular place that, even on the enterprise side as well as on the public side, people are building these blockchain use cases. But an EVM is a fully shared ledger, which means every transaction that's executed on it, everybody validates it. Everybody runs the same transaction and comes up with the same conclusion, which means everybody has a copy of the same data. That's extremely powerful. If you think about a lot of the data that happens inside of enterprises collaborating together, it's actually very sensitive and private to the people who are transacting. And you don't always want to share all of that data with everybody who's involved in these transactions. You want transactions to be able to have, we say, sub-transaction privacy, sub-ledger privacy, so that different parties can have different views on those transactions. This has been a problem that's been really significant for every enterprise project for as long as enterprise blockchain has been around. There are many different technologies over time that have evolved, but it's been very difficult for any project to have a resilient and reliable engine to put this sort of layer of privacy on top. So the evolution of Kaleido, which has been a very significant new project, it's just actually become a full project in the Linux Foundation Decentralized Trust stable, going over the last year and a half from a lab. And it brings together advanced cryptography, things like zero-knowledge proofs, with practical approaches to privacy, like notary-based tokens, and the next generation of technology from, I mentioned Tessera earlier, which came after Constellation, the next generation of what are called privacy-preserving smart contracts, or privacy groups, which allows little groups to get together and run smart contracts independent from the ledger underneath. So we think of Kaleido a little bit like a privacy set of goggles that sits on top of the shared ledger without changing that shared ledger in any way. And every transaction that happens is fully verified by the base EVM ledger that everybody is sharing, but the data and the cryptography it happens in a sort of sidecar, a separate runtime, sitting alongside that underlying technology. So we're going to talk mainly about the roadmap, but I wanted to introduce this because if you are looking at doing an enterprise project and you really want to share and get a ledger between multiple parties, and you want to get value out of that, you may well find that privacy is necessary to introduce in addition to having a robust shared ledger layer like LFDT Besu. We're going to talk a little bit about some more low-level items, and we'll sort of go through these pretty rapid fire, but some of them are very interesting. So we think about a blockchain creating blocks on a regular period. It's very common for that to be a few seconds apart. What if you want to have transactions with very low latency? You want sub-second latency, for example. Those blocks have to come fast, like block after block after block after block. And that's very inefficient if nothing's actually happening, to have these blocks going multiple times a second. So there's a great feature that's gone into Besu this year, and it's just moving from experimental into sort of full support now, to allow blocks to be created only when there are transactions, but very fast. So you can say, I want my blocks to happen in every 100 milliseconds, but if there are no transactions to create, don't create any blocks for 20 seconds. And that means when it's inactive, no blocks will get created for 20 seconds. When it's really active, your transactions go through really fast. So it's an example of a low-level feature, but you can see how that really raises up to needs of enterprise, because you want those transactions to have low latency. Some example of things that enterprises really care about: mutual TLS support has just come in for the WebSockets interface on the blockchain, as well as the HTTP interface. So quite a low-level feature, but the sort of thing that enterprises really care about. That's something that actually Kaleido introduced into the roadmap this year. And there's this one's, this is the slide that's got all of the hex on it, right? This is the low-level sort of detail that you're really interested in if you really understand EVM. But actually there's a point on this which is really important. Blockchains are actually very hard to diagnose when they go wrong. Most blockchain technologies. The LFDT Besu project has put more effort in than any other EVM blockchain technology to giving you the information about how things happened when they worked, tracing those transactions, giving you information about what happened inside of them, and when something goes wrong, getting that information out. So this feature, extending out the call and ETH after gas capabilities, is actually like a little micro item on a journey that's continual on LFDT Besu, of making blockchain predictable and explainable, so that you can understand what happened when transactions go right and when transactions go wrong. So there's lots of other smaller features. I'm actually going to sort of whistle through some of these items, and we're going to talk about a slightly bigger one that came through this year. This was the feature around recoverability of the QBFT consensus protocol. I'm going to skip past this. And we're going to talk about Bonsai, which is actually really a really heavy lifting bit of engineering that's happened this year. And so there's a little bit of a sort of history lesson here. There's a feature, there's a thing called Forest, which is the way that blockchains have been managing their data for the longest time. And Forest basically says you maintain every sort of state, every bit of data that the blockchain ever knew about. You maintain it in a way that it's all there, and you can ask the blockchain a question at any point in history, and it can find it in that forest of data. It's very, very efficient at being able to go back and look in time. But you're storing data in this the very large sort of entangled mess of data, which is actually quite difficult to manage at scale. And what's happened this year is that we've actually taken a new way of storing data, which is called Bonsai, which existed for about a year in the public side. We've fully supported it for enterprise, and we've filled in a bunch of gaps in terms of things that it can do. So this new thing called Bonsai, I actually want to talk about more about how it works. It's really interesting. Instead of storing everything in one big mess, what it does is it says, we're going to create checkpoints. And we're going to store the differences between those checkpoints. And if you want to go back and answer a question in history, instead of just looking at the data it is right now, you go and load the checkpoint from that time, the one most recent before the history you want, and then you play forwards from that. And that's a very sort of low-level technical description of how the data gets managed. But this is really the interesting thing. This is a graph showing the amount of data which actually gets stored for the forest database. And if you imagine blockchains for enterprise running hundreds of transactions a second for many months and years, right? That sort of blockchain scale, we're talking about a lot of data, a lot of blocks over a lot of time. The scale with Forest in terms of how much storage it uses on disk was very problematic. It just goes up and up and up and up. Whereas with Bonsai, you can just see the gap between here of how much more efficient it is on storing on storage. So this is the kind of stuff that's really heavy lifting engineering, and it's great within the Linux Foundation that we've got contributors. Obviously a lot of people in my team in Kaleido, but Consensus and others that are really contributing to this project, and it's quite a wide community for the Besu project. But we can get these really meaningful, heavy engineering items in really matter to enterprise, because how much storage the system is going to use and how it scales, you've really got to answer questions on that from the engineering side when you're reporting up into an organization. So in the last bit of this session, we're just going to talk a little bit about the future and where we're going with the enterprise roadmap for Besu. And I just want to talk about some of the things that are coming actually in the mainnet that are going to be really relevant to enterprise. One is this idea of history pruning, of actually the mainnet going through a journey where it's actually going to be less of a requirement for nodes to actually be able to hold on to the whole history of the mainnet. And this is going to be a journey that's going to be very interesting to blockchains that are in, I work with blockchains that are in the hundreds of millions of blocks, and you think about looking after 100 million blocks of history, that's a lot to look after. Wouldn't it be really nice if we could prune some of that? So some of the work that's happening in the public mainnet is going to be really interesting, and through next year we're expecting to see some real evolution of that coming into enterprise blockchains as well. And the overlap between the two, because there's obviously enterprises working with public and private blockchains a lot, certainly the ones that we're working with. There's some low-level stuff happening in terms of network topologies and gossip-based sharing, going from validators, the ones who create the blocks, needing to directly peer with each other, to being able to do intermediate peering, where the non-validating nodes can share, and that's all very gossipy. And it's interesting if you're really embedded in the space. I think the one that I really want to mention is, rather than this one, which is lower level, I really want to step back and talk about where we're going with the code base. So I mentioned that there's been an exercise of taking hard decisions to pull features out of the code base to make it more nimble, make it easier for developers from the side of the Ethereum core maintainers. But there's primarily that is what Besu is part of that core engineering of the Ethereum Foundation. It is a core client for that, and that they need to go fast, and enterprise needs to go fast. And actually, one of the reasons for pulling out some of the features was to move to a world of modularity in the code base, where we can actually have the ability for enterprise features that are needed not for those mainnet chains, but are needed for all of these blockchains which are independent, these separate L1s that are being created using Besu across a set of financial institutions, other large enterprise organizations, maybe the tokenized deposit infrastructure of a bank. There are specific features that they need, and we need to be able to go fast with them. And we need the engineers who are contributing those to be able to do that in the code base without slowing down the engineers that are trying to just keep up with this constant treadmill that is the public mainnet Ethereum development cycle. So actually a lot of the trimming that's happened this year is going to turn into a journey of modularity next year, which is really exciting if you're really embedded in the way the code base is working. So if you're worried about why some of those features are going from the code base, it's so that we can do this. And it really matters for this project to have the longevity that we need, right? The chains that are started now, they need to have that support in many years' time, and that means we need this project to keep up with the mainnet, and we need it to also have the enterprise roadmap involved. Another feature that it's not the time to talk about in detail, but it's really exciting if you're nerding out on the way these data structures work, Vertical trees are a fundamentally different way to store and manage the state of blockchains that allows some really efficient things to be doing in terms of how you can trust the data from a blockchain while having a lot less of the data there available to you. It's a different way of structuring the data to allow proofs of data being valid to be done with a lot less access to the data. And this is actually one of the most significant items that's happening in the mainnet, and that's also going to filter through to enterprise use cases as well. So lots of information in this session. I hope you've got a feeling for how much within the Linux Foundation Decentralized Trust, with organizations in the core maintaining community like Consensus, like Kaleido and the others that are involved, but we're juggling trying to make sure that this client stays up, relevant, fast in the mainnet community across lots of L2s and mainnet Ethereum being the reference client there, but also having a continual focus on the features that are needed for enterprise, HADR, scale, efficiency, speed, latency, the ability to run small groups of nodes reliably rather than just thinking about networks that have tens of thousands of nodes, and that we're juggling those together. And it's going really well. It's a great community to be an engineer as part of, as me and my team are. And it's a community that is having a great pace of adoption now, as EVM becomes so popular for use cases for enterprise in the financial industry and others, for digital assets, stable coins, tokenized deposits, central bank money, all kinds of different scenarios on the cash legs, but also these asset legs, creating the assets that can be traded, tokenizing bonds, tokenizing other securities and funds, etc. And those all coming together, and Besu being the place that it's already happening. Okay, well, thank you very much for listening to us today.